What if the first sign of intelligent life beyond Earth wasn't a radio message, a spacecraft, or even a biological signature? What if it was simply light? For decades, scientists have searched the cosmos for evidence that we are not alone. Thousands of planets have been discovered orbiting distant stars, yet none have provided definitive proof of extraterrestrial life. Now, attention has turned once again to one of the most fascinating worlds ever discovered, Proxima Centauri b. Located approximately 4.24 light-years from Earth, Proxima Centauri b circles Proxima Centauri, the closest star to our solar system. Although the planet is much too distant for humans to visit with current technology, its relative proximity makes it one of the most important targets in the search for life beyond Earth. Recent observations and scientific discussions surrounding this distant world have sparked intense curiosity. Researchers examining faint infrared signals associated with the planet have identified unusual patterns that remain difficult to explain. While no conclusions have been reached, the observations have raised a fascinating question. Could advanced technology be responsible for some of these mysterious emissions? Before jumping to extraordinary conclusions, it's important to understand what makes Proxima Centauri b so special. The planet orbits within what astronomers call the habitable zone. This is the region around a star where temperatures may allow liquid water to exist on a planet's surface. Since water is considered one of the essential ingredients for life as we know it, worlds within habitable zones receive special attention from scientists. However, Proxima Centauri b is not simply a second Earth. The planet orbits a red dwarf star, a type of star that is smaller and cooler than our Sun. Red dwarfs are the most common stars in the Milky Way, but they are also known for their powerful stellar flares. These eruptions can release enormous amounts of radiation, potentially threatening the atmospheres of nearby planets. Because Proxima Centauri b orbits very close to its star, many scientists believe it may be tidally locked. This means one side of the planet permanently faces the star while the other remains in constant darkness. If true, the planet would have a permanent day side and a permanent night side, creating environmental conditions unlike anything on Earth. Despite these challenges, some researchers believe life could still exist there. A sufficiently thick atmosphere might distribute heat around the planet and protect the surface from harmful radiation. In such a scenario, habitable regions could potentially develop along the boundary between the day side and the night side. This is where the mystery becomes especially intriguing. Modern telescopes, including the James Webb Space Telescope, are capable of studying distant planets in remarkable detail. By observing infrared light and analyzing how starlight interacts with planetary atmospheres, scientists can gather clues about the composition and characteristics of worlds far beyond our solar system. Some observations connected to Proxima Centauri b have revealed faint and recurring signals that do not yet have a clear explanation. While natural processes remain the most likely cause, the consistency of certain patterns has encouraged scientists to investigate multiple possibilities. One of the more imaginative theories involves artificial illumination. If an advanced civilization lived on a tidally locked planet, artificial lighting could play an important role in life on the permanently dark hemisphere. Vast cities, industrial complexes, transportation networks, or energy facilities could theoretically produce detectable light emissions under the right circumstances. From great distances, such illumination might appear as unusual glows or recurring patterns. Although current technology is not yet capable of directly identifying alien cities, researchers have explored how future telescopes might recognize large-scale artificial lighting on exoplanets. Another possibility involves advanced energy systems. Instead of city lights, unusual emissions could originate from enormous solar collectors, orbital infrastructure, communication networks, or other technological projects beyond our current understanding. Some scientists have even suggested that highly advanced civilizations might intentionally create visible signals to announce their presence. Directed energy systems, powerful lasers, or other forms of light-based communication could potentially be detected across interstellar distances. Yet caution remains essential. History has repeatedly shown that mysterious astronomical observations often turn out to have natural explanations. Pulsars, for example, were initially so regular in their signals that some researchers jokingly considered the possibility of extraterrestrial intelligence before discovering their true nature as rapidly rotating neutron stars. The same scientific skepticism applies here. There are numerous natural mechanisms that could produce unusual light signatures. Volcanic eruptions, atmospheric interactions, magnetic activity, thermal emissions, and complex weather systems may all create patterns that appear unusual when observed from trillions of kilometers away. Understanding these possibilities requires detailed atmospheric analysis. Scientists search for potential biosignatures by studying the chemical makeup of planetary atmospheres. Certain combinations of gases may indicate biological activity. Oxygen, methane, ozone, and carbon dioxide are among the substances researchers examine closely. On Earth, many atmospheric gases are strongly influenced by life. If similar patterns were found elsewhere, they could provide valuable clues about the presence of living organisms. However, interpreting these signals is extremely challenging because many non-biological processes can produce similar chemical signatures. The search for life therefore relies on gathering multiple lines of evidence rather than a single observation. Future observatories will play a crucial role in solving these mysteries. Several next-generation projects are expected to dramatically improve our ability to directly image exoplanets and analyze their atmospheres. Advanced starlight blocking technologies may allow astronomers to separate the faint glow of a planet from the overwhelming brightness of its host star. Ground-based observatories are also becoming increasingly powerful. Massive telescopes equipped with adaptive optics will provide sharper views of distant worlds than ever before. Combined with future space missions, these instruments may eventually reveal whether Proxima Centauri b possesses oceans, clouds, an atmosphere, or even signs of biological activity. For now, no credible scientific organization has announced evidence of alien civilizations on Proxima Centauri b. The observations remain under study, and natural explanations continue to be the most scientifically supported possibilities. Yet the excitement surrounding these investigations reflects something deeper than any single discovery. Humanity has always looked toward the stars and wondered whether other minds might exist among them. Every new telescope extends our vision farther into the cosmos. Every new planet discovered reminds us that our solar system is only one small part of a galaxy containing hundreds of billions of stars. Perhaps the mysterious signals from Proxima Centauri b will eventually prove to be entirely natural. Or perhaps they will reveal something we have never encountered before. Either way, the search itself is transforming our understanding of the universe. And somewhere, beyond the darkness between the stars, answers may be waiting to be found.